Have you ever wondered why the water coursing through your veins behaves less like the liquid in your glass and more like a living crystal powering every heartbeat?
Welcome to Dr. Mercola's Cellular Wisdom. Stay informed with quick, easy-to-listen summaries of our latest articles, perfect for when you're on the go. No reading required. Subscribe for free at mercola.com for the latest health insights.
Hello, and welcome to Dr. Mercola's Cellular Wisdom. I'm Ethan Foster, and today we're turning the spotlight on water's overlooked fourth phase, the liquid crystalline state that quietly drives your muscles, nerves, and microcirculation.
I am Alara Sky. Most of us learned water exists only as solid, liquid, or vapor, yet research stretching from Victor Schauberger's spiraling mountain streams to modern laboratory work shows it can assemble into a gel-like lattice inside and around your cells. This structured form, often called exclusion zone, or EZ water, turns ordinary H2O into H3O2 and transforms chemistry into directed biology, creating electrical separations that standard textbooks can't explain.
In 2009, Gerald Pollack demonstrated that microspheres dropped near a hydrophilic surface were pushed away by an invisible barrier. That barrier turned out to be layers of hexagonally stacked water molecules, each layer offset, sliding smoothly over the next, creating a liquid crystal with about 100,000 times the conductivity of bulk water and forming sheets up to 1/10 of a millimeter thick, large by molecular standards.
Those sheets appear whenever a negatively charged surface meets ambient infrared light, energy that exists everywhere, from warm sunlight to the mild radiation your own tissues emit. As water restructures, protons are expelled, leaving the EZ negatively charged while the surrounding zone becomes relatively acidic. Laboratory setups have harnessed this separation to light small LEDs, proving water itself can store and release usable energy without any moving parts.
Inside you, that stored energy isn't a laboratory curiosity. It's working every second. Liquid crystalline layers line cell membranes, mitochondria, and blood vessels, giving tissues firmness, shielding joints and arteries from wear, and creating lubricated planes so tendons glide instead of grind. Without it, cells would leak, vessels would scar, and movement would feel sand-filled rather than fluid, making every gesture a strain.
Capillaries present a puzzle. Many are narrower than a red blood cell, yet blood traverses them with ease even where heart pressure disappears. Pollack's team solved part of that mystery by showing that hydrogels, materials rich in EZ water, generate spontaneous flow inside microtubes with no external pump. Light intensifies the effect, and the narrower the tube, the faster the flow, exactly what physiologists observe in your smallest vessels.
The heart enhances this self-propelled stream by imparting a spiraling twist, a motion Soviet researchers likened to tiny tornadoes that keep blood elements arrayed by weight and function. In this model, the heart behaves less like a hard pump and more like a precision timing valve that modulates a flow already energized by structured water and ambient light coursing through your tissues.
Nature offers visible clues to the same phenomenon. The surface layer of a pond forms an EZ strong enough for water striders to skate effortlessly. Basilisk lizards exploit it to dash across rivers, their feet never fully breaking the liquid crystalline skin. When you watch ripples spreading in concentric rings, you're seeing ordered sheets transmitting force as a united membrane rather than loose, sloshing molecules.
Red cells stay evenly dispersed because each carries a negative surface charge, its zeta potential. Liquid crystalline water reinforces that charge. Lose it, and cells clump, thickening blood and blocking microvessels. The article notes that aluminum adjuvants and dense charge spike protein fragments overpower this delicate balance, helping explain why certain injections or infections precipitate microstrokes throughout sensitive tissues.
Consider chia seeds swirling in a glass. When soaked, each seed develops a clear gel coat, EZ water creating a barrier that stops gravity from separating seed and solution. If the coating is incomplete, seeds sink. Your bloodstream is similar. Keep the lattice robust and nutrients remain suspended. Let it collapse, and heavier elements settle where they can do harm.
Phase shift control is another payoff. Muscles hold liquid crystalline water that stretches contractile proteins. A surge of calcium collapses the lattice, letting fibers snap short, while ATP rebuilds the charge and resets the stretch. Nerves fire by a comparable soul-to-gel flip, and vesicles eject their contents when localized EZ melts, illustrating that water structure is biology's quickest switch.
Plants rely on identical physics. Xylem tubes generate easy layers that pull sap upward against gravity, demonstrating that radiant energy and charge separation, not mechanical pumps, are enough to move water stories above the forest floor. Observing a tree on a warm afternoon offers a living mirror of the silent flow inside you.
Factors that strengthen your internal lattice track closely with those that raise zeta potential. Steady exposure to gentle infrared warmth, adequate alkalinity, and minimizing agents that deliver dense positive charges. While the article stops short of prescribing a protocol, it's clear the environment you create within and around you determines how robustly your water assembles and how smoothly your microcirculation operates.
Pollack argues that funding priorities reward incremental projects, not audacious quests for root mechanisms. As a result, phenomena like easied water remain sidelined, even though they answer riddles from capillary flow to joint lubrication. A research culture eager for secure grants often shies away from discoveries that demand rewriting core assumptions.
Policy leaders within the Making America Healthy Again initiative, including RFK Jr. and NIH Director Jay Bhattacharya, are now pushing reforms to open research paths that welcome foundational questions. Their goal: let evidence, not entrenched dogma, decide what deserves investigation and funding, returning curiosity to the center of biomedical science.
Structured water matters on a personal level, too. As EZ layers thin with age or chronic oxidative stress, tissues dehydrate, zeta potential drops, and circulation falters, setting the stage for the degenerative changes we call normal aging. Protecting that lattice could therefore be one of the most direct ways to preserve vitality well into later years.
Before the day ends, pour filtered water into a clear dish, place it under gentle sunlight or near a warm lamp, and watch the subtle skin that forms on its surface. That thin film is structured water, the same phenomenon working invisibly inside you. Take a photo or jot a note about what you observe, then share that insight with someone close to you. Recognizing water's hidden dimension is the first step towards supporting it. Thank you for watching Dr. Mercola's Cellular Wisdom. We'll see you on the next episode.
Thanks for watching. Subscribe now and click the notification bell so you never miss an update. See you in the next video.